Good morning, students. Today we'll see about your next topic, that is equipotential surfaces. So just to explain the concept of equipotential surfaces, if we take any small charge, suppose this is a small charge Q, and because of this small charge, we will see the effects of that charge in surrounding atmosphere. So if this is a small charge, and if this is if at a radial distance of r, effect of this charge will be whatever the effect of this charge at this point, so you will see the same effect at this point. Okay, sorry, you will see the same effect at this radial distance of r. Same way at this radial distance of r, or at a radial distance of this also, you will see the same effect. So means for this charge Q, we will see one imaginary spherical surfaces. Okay, and all those spherical surfaces are concentric at this point Q, at this point where the charge is Q. So the value of this equipotential, the value of this electrostatic potential, that is V is equal to kq upon r. So at a radial distance of r, the value of electrostatic potential, that will be same. If we change this radius, the value of electrostatic potential will be different. So that imaginary surface, okay, so equipotential surfaces are what? That is the imaginary surfaces are which are concentric at this center of the sphere. Okay, सपोज एक स्फीयर ले लिया, स्फीयर जो भी स्फीयर की जितनी भी सर्फेसिस है, ऑल दो सर्फेसिस आर कॉन्सेंट्रिक एट वन सिंगल पॉइंट. So same way, this imaginary surfaces which occurs because of this electrostatic potentials, so all those imaginary surfaces are concentric at this point, so that's known as a equipotential surfaces. And on these equipotential surfaces, the electric field lines, if I am drawing this electric field lines, so that electric field lines that will always be normal to these equipotential surfaces. The electric field lines that will always be normal to these equipotential surfaces. Okay, so that is the concept of equipotential surfaces. Now suppose I am taking a small charge, and because of that small charge, I will have these equipotential surfaces. So close to this small charge, these equipotential surfaces are having a vast difference in the value of this V. But as I am going away, so it will be around parallel, and the changes in this equipotential surfaces, that will be changes in this equipotential surfaces, that will be very small when we go far away from this center point or from this charge. Clear? And suppose I am taking a point Q over here, and if I am bringing this Q from this point to this point, so obviously as per the concept, I have to apply some work on it. Okay, but in case of equipotential surfaces, as we know that this charge is Q, and the value of electrostatic potential V, that will be same at both the points. So here, to bring the charge from this point to this point, work is being applied on the charge, and from this point to this point, work that is being done by the charge. So overall net work done, that will be equal to 0. Clear? So on a given equipotential surfaces, the value of a charge is same, and also the value of electrostatic potential will be same. Okay, so I hope the concept of this equipotential surfaces is clear. So again, I am just repeating, equipotential surfaces, that are the imaginary surfaces that are concentric at the center of the sphere, and at the center you will have charge Q, and at all the equipotential lines at a radial distance of r, the values of equipotential electrostatic potential will be constant. And another thing, that is that electric field lines drawn through these equipotential surfaces, that will always be normal to this equipotential surfaces. Okay, and to bring the charge from one equipotential surfaces on the same from one point to another on the same equipotential surfaces, the net work done, that will be equal to 0. Sorry, the net work done, that will be equal to 0. Clear? So that was the concept of equipotential surfaces. Now next topic is potential energy of system of charges. Okay, so suppose this is charge q1, suppose this is charge q2, and the distance between both, that is r, and this is as a vector representation. And initially potential energy of system of charges, 2 points are there. One, that is for potential energy for a system of, for this system of 2 charges, and in another case that potential energy for system of 3 charges. Okay, so suppose this charges q1 and q2 both are at infinite initially. Okay, so now initially this charge q1 is bring from infinite to this point in a given electric field. At this point the charge is q1. Okay, and we just assume that no work is done to bring the charge from infinite to this point. So in that case w1, that will be equal to 0. Now to bring this charge q2 from infinite to this given point in a given electric field, we have to to bring this charge q2 from infinite to this given point in a given electric field. Here work is done on this charge q2 because of this charge q1. So that value of that electrostatic potential, or the value of as we know that as per definitions, the electrostatic potential is what? W upon q. So for this charge q2, we will have the equation is w2 is equal to q2 and electrostatic potential because of this q1. Okay, so q2 as it is, and that will be k q1 upon r. R is what? That is r 1 2. Okay, so this is what a work is done on the charge q2 because of this charge q1. So the equations will be w2 is equal to k q1 q2 upon r 1 2. So the total work done, and this work done is what? That whatever work done, that is utilized in the storage of the potential energy. So that is also known as the potential energy, and total work done, that is equal to w1 plus w2, but w1 is 0, so that is equal to k q1 q2 upon r 1 2. Clear? So that is when the system of 2 charges are there. So this will be the equation for potential energy for a system of 2 charges. Now in place of these 2 charges, if I consider the system of 3 charges, so your topic is the for system of 3 charges. So for the system of 3 charges, these are the 3 points, 3 different points. This is O. Suppose this is Q1, this is charge Q2, this is charge Q3. So this is at a radial distance of R1, this is at a radial distance of R2, and this is at a radial distance of R3 from this point O. Now I am joining all these 3 points Q1, Q2 and Q3. So here this will be R12, this is R 2 3 and this is r 1 3. Okay, so in that case initially we have to just explain that suppose consider three different charges q1, q2 and q3 which are initially at infinite. Now to bring all these three charges q1, q2, q3 from infinite to the given point in the given electric field, the work is done, and initially we just assume that work is done on the charge q2 to bring it from infinite to this given point, so that work done w1 is equal to 0. Okay, now to bring this charge q2 from infinite to the given point, so work is done on this charge q2 because of this charge q1, so that w2 is equal to, that is q2 into v because of this q1. So q2 as it is, that is k q1 upon r12, so that will be the k q1 q2 upon r12. Clear? Now for this third charge q3, now to bring this charge q3 from infinite to this given point, work is done on this charge q3 because of this charge q1 and q2. So in that case w3 that is equal to q3 electrostatic potential of q1 plus q3 electrostatic potential of q2. So that equation will be k q1 q3 upon r13 plus k q2 q3 upon r23. Okay, so this is the equation of work done w1, w2 and w3. So total work done, or from principle of superpositions, w is equal to w1 plus w2 plus w3. So we have to just put this value of w1, w2 and w3. So finally we will get this equation of work done, and whatever work is done to bring this charge from all these three charges from infinity to given point, so that work done that is utilized into the storage of this potential energy. So that total work done we can say it as a potential energy U. Okay, and in generalized form we can write that equations of potential energy as sigma I is equal to 1 to n, where I that is less than j, k qi qj upon r ij. Okay, so that will be the generalized equation for this system of three charges. So just remember that here in this case, to find the value of potential energy of system of charges, two charges and three charges, we are just considering that whatever this electric field is generated, that is because of this or given electric field. And next time whenever we will going through another theories, so in that potential energy is generated because of external field. Here this field is already given, here also the field is given, but now onwards we will see the theory in which that potential energy is obtained in a given charge because of this external field. Okay, thank you.